Okay, guys, this is exam 3, question number 6. And just know that I have, when you see different colors on here, I just did that so that it's easy for us to track doing the problem. The original problem was in black and white. Let the universal set be the set of all real numbers, and let A equal the set containing all x that are in the real numbers, such that 0 is less than x, which is less than or equal to 3. And B is the set containing all x in the real numbers, such that 1 is less than or equal to x, which is less than 4. Find each of the following. So the first one is A union B. But before I get started, I'm just going to draw a number line. Okay. Um, I guess I'll do it here. Okay. I want to visually see what I find this notation to be sort of difficult for me to wrap my brain around it. So I just want to see what it looks like visually. All right, so the lowest possible number would be -1, 0, 1, 2, 3. I need 2 more lines. Okay, 4 and 5. And this is why I did things in different color. So for A, x is between 0 and 3, including 3. So I will put a empty circle at 0 because it's not including that number, and a filled circle at 3 because it's including that number, and then draw a line between the two. That is A. Okay. So now for B, x is greater than or equal to 1 and less than 4. So it's not including 4, so empty circle here. 1 it's including, so a solid circle here. And I'll draw a line between the two. That's B. All right. So now I'm going to find A union B. So what is A union B? It's all the elements in A and all the elements in B. And so as long as it's somewhere in between those two. So I have A union B is starting at 0 but not including it, all the way to 4, not including it. So A, just be sure. Yeah, okay. Excuse me. So A is A union B. Is equal to the set containing all x in the real numbers, such that, so not including 0, so that's less, or 0 is less than x, and not including 4, so less than 4. And that's it for A. Now for B, this is A intersects B. So that is where this is all numbers that are in both A and B. So not 0 because it's only in A, and not 4 or whatever, 3.5, 1.5, or 0.5 rather. Right? So what is the only things that are in both sets? Well, starting here from 1, including 1, to 3, including 3. So A intersect B is equal to the set containing all x's that are real numbers, such that, all right, so starting at 1, including it, all the way up to 3, including it. And there we go. Now we want a complement, and so that's everything not in A. So, and I'm going to do a different color here. All right, so this is what everything, so it's not anything here. I'll put a circle here and I'll put a circle here. Because this is this empty circle, I fill the circle, right? Because I'm going to include 0 because it wasn't included in A. And I'll leave the circle empty because it does include 3 on A. So it's literally everything that A is not. And notice where my arrows are pointing. Everywhere besides the center part, okay? That's A complement. So A complement is equal to the set containing every x that's a real number, such that x is less than or equal to 0, or x, let me just do this right. No, I'll do it in the same order. X is greater than 3. Okay, that's it for C. Finally, for D, we're taking two complements and finding the intersection. So I'm going to find, I already have my A complement here in pink. I'll use green for my B complement. It's the same sort of tactic. It's going to be a circle here that's empty because this one's filled, and a circle here that's filled because that one is empty. It's literally just the opposite of B. Right? And so what is our intersection? Well, that's all the numbers that are in both sets. So for instance, 0.5 is not in there because it's only in B. So it's going to be from here this way, including that 4 and including that 0. So A complement intersect with B complement is equal to the set containing all x in the real numbers, such that, oops, okay, so x is less than or equal to 0, or x is greater than or equal to, or, yeah, that's fine. I'll do it the other way around. 4 is less than or equal to x. And we're done. That's it for this problem.